Go on the road. Hi, everyone. Welcome to the Physionic Podcast. If you're not familiar with who I am, if you are familiar with who I am, then you know this intro is pretty familiar. If you're not familiar, my name is Nicholas Verhoeven. I'm a PhD student in molecular medicine. I have my master's in exercise physiology, and today we're going to be discussing a really interesting paper, as usual, on alternate day fasting and its impact on a series of different markers, cholesterol, hormones, 3 specific hormones. Also looking at, this isn't necessarily something that they were focused on, but we're also going to be able to tell what impact this has on lean mass, more specifically on muscle mass and fat mass. So the name of the study, if you are watching this, if you are watching either live or after the fact, I will have that up for you. But as usual, if you're just listening to the podcast, you'll be able to follow along just as well. So the name of the study that we're going to be covering is Improvements in Coronary Heart Disease Risk Indicators by Alternate Day Fasting Involve Adipose Tissue Modulations. Honestly, reading that probably doesn't tell you a whole lot of information, but needless to say, we'll be going through each section as needed. Okay, so to give you a bit of background on alternate day fasting, and then I'll give you a bit of background on these different hormones, and then we're going to go into a bit of the study design, and then we're going to go into the results and try and figure out what we can actually take away from this study. As usual, if you want to know more details, you can hop on over to Instagram, where I tend to post some of the data and kind of do a little bit deeper dive or have different perspectives on things. But if you are watching the podcast, then you will see some of the data pop up on the screen as we go forward. Okay, so what is alternate day fasting? Alternate day fasting is a form of intermittent fasting, and if you have been at least somewhat familiar with intermittent fasting, then you know that alternate day fasting is similar, or really pretty identical, to what's called as eat, stop, eat fasting. So it's exactly as it sounds. You have a 24-hour period where you're allowed to eat, and usually it's ad libitum, meaning that you can consume as much as you want. And then the next day, you typically either consume nothing or you consume incredibly low levels of calories. And that's probably something that you want to be pretty cognizant of. So in this study, they're using 25% of maintenance calories. So they determine, and I guess I'm jumping ahead a little bit, but they determine maintenance calories for these participants. And then off of that, they cut down 75% to leave them at 25% of their maintenance calories for their quote-unquote fasting day. And then the next day, of course, they're allowed to consume as they want. So the study wanted to investigate the effect that ADF, which is alternate day fasting, you might see that on the screen, and I may refer to it as ADF, alternate day fasting, has on cardiovascular health, specifically because they're going to be looking at a variety of different markers for cholesterol. But again, we can actually get some more information out of this study that's not just about cardiovascular health, as well as some potential mechanisms for this effect. So what effect alternate day fasting has on cardiovascular health. So the 3 hormones that they look at are adiponectin, which you may or may not be familiar with. I've spoken on it a little bit in the past, but not a whole lot, and I'm sure I'll be releasing a lot more content on that because it is a really interesting hormone that not a whole lot of people discuss. The second one is leptin, which I have spoken on quite a bit, and I'll be speaking on again. And the final one is one that actually I need to do more research in because it's not discussed very much. And I believe they mentioned that this is the first study to ever look at, I don't know if it was fasting or if it was alternate day fasting specifically, and its impact on resistin. So that is the hormone. And to give you a bit of background on each one of these hormones so that you're not left in the dark, adiponectin, so all 3 hormones are adipokines, meaning that they come from adipocytes, meaning that they come from fat cells. But they're not exclusive to fat cells, at least not 2 of them. Adiponectin can actually be produced by our skeletal muscle, by our smooth muscle, and I believe by our heart muscle. I could be wrong on that, but definitely the first two, so skeletal muscle and smooth muscle. So it's not specific to fat cells, but maybe it was identified in fat cells first. And of course, it's got the name adipo, which is alludes to adipocytes, fat cells. So adiponectin and leptin and resistin are all three released from fat cells, but adiponectin can be released from other cells, as well as leptin can also be released from other cells. Although not very many sources discuss that, but it can be released, for example, from the gastrointestinal system. And I may have mentioned that actually in the last podcast, or maybe the podcast before, where they looked at leptin. I think both, actually. So leptin is released from the gastrointestinal system, but it's mainly released from fat cells. So what do these hormones do? Adiponectin, when it's increased, and this is going to be really vital for us to understand, I'll repeat it later on when we go through the actual data, but when it's increased, the levels of adiponectin, when they're increased, are associated with better cardiovascular outcomes. Now, that is at least partly because adiponectin inhibits monocyte binding to endothelial layer. Okay, let me break that down. I wish that I had a graphic for this. I wish I created one, but I completely slipped my mind. But what does that mean? So monocytes are essentially immune cells. And if we get the production of, if you've ever heard of the disease atherosclerosis, which is essentially plaque buildup in our arteries. So essentially you have a tube, right? That is your artery, that is your blood vessel. And if you have plaque buildup, think of it, I always use this analogy, a hose, and you put your thumb just a little bit over the hole as the water's coming out, then that starts to build a little bit of pressure, and that's an increase in blood pressure. So hopefully I'm making that relationship. But as plaque builds up, that's like putting your thumb more and more over that hose hole so that the pressure continues to build, and eventually you get to a point that if the thumb is completely over the hose, then obviously you can't stop the water completely, but that's essentially what's happening in the vessel. So you have this plaque buildup that continues to build within that small space, or that limited amount of space, and that ends up creating what's known as atherosclerosis. And you get increases in blood pressure, and then you get problems with thrombosis, which is kind of breakages of these plaques that get trapped in other areas of the body, which then lead to potentially stroke, a particular type of stroke known as ischemic stroke, or it can lead to other cardiovascular issues. Essentially, it's incredibly painful and it can be life-threatening. So how does this apply to monocytes? Just to go back to the original point. Monocytes are immune cells that when we have cholesterol, too much cholesterol, specifically LDL cholesterol, VLDL cholesterol, if these cholesterol particles get stuck on kind of the layers of this wall that makes up this vessel, then the monocytes will go up to that area, to those LDL particles that are stuck, and actually infiltrate into what's known as the endothelial layer, which is one of, you can think of it like the rubber that makes up the hose. Okay, so it is part of that vessel, and it controls and allows that vessel to behave a certain way, if that's enlargement, if that's shrinking, whatever it needs to do to make sure that it's maintaining the health of that vessel. So as LDL particles get stuck to that area, monocytes will migrate to that area and stick to the endothelial cells, then migrate through the endothelial layer, and then gobble up these LDL particles, and then they end up forming into what's known as foam cells. And these foam cells then undergo a bunch of different processes, but eventually they end up dying. And these foam cells, if they build up, that starts to create a pressure for the endothelial layer to start pushing upwards. So suddenly you have this bump that's within the blood vessel. And with this bump, as this continues to grow, you get more and more shear stress that's occurring as blood flow is going across that bump. That slowly starts to lead more LDL particles to get stuck to that area, and you get this cycle that continues. So the bump continues to grow, and it continues to grow, and then the atherosclerosis is essentially born. You get this slowly decreasing size of the artery or the blood vessel, whatever blood vessel that ends up being. It doesn't necessarily have to be an artery, but I think it's typical to arteries. So how does adiponectin play into this? Well, it actually inhibits the monocytes from binding to the endothelial layer. So although the LDL particles might get stuck there, at least you don't have these monocytes that are ending up in that location and then dying off inside the endothelial layer, starting to perpetuate this bump or this plaque formation. Leptin, on the other hand, is certainly attributed to energy homeostasis. So if you suddenly start to eat a lot less food, one of the mechanisms that controls your metabolism is leptin. So leptin will go from a high state and actually decrease. So you are seeing a decrease in leptin, and you typically want to see an increase in adiponectin. So make sure that you kind of keep that straight in your head. But again, I'll repeat it later on. So leptin is not only in control of energy homeostasis, and of course, I'm simplifying things. These hormones have impacts all over the place. That's what makes the human body so incredibly intricate and interesting. But leptin also has an effect on platelet aggregation. So if you get wounded, if you have, let's say you cut yourself and you're actually bleeding, you have platelets that go to that area and essentially close that wound up. It kind of create an initial seal that needs to happen. So these proteins that are known as platelets go to that area. Now, if you have too many of these platelets, unfortunately, they can aggregate, so they can stick to one another, creating what's known as a thrombosis. So this thrombolytic protein, that's these aggregated platelets, can get stuck in smaller vessels of the body, smaller arteries or arterioles and venules, and these kind of baby versions of the full-fledged artery. Like if you look at your brachial artery, for example, that's a really big artery. That's not going to get filled up with this particular problem, but smaller ones will, and that can be, again, extremely painful, and it can be dangerous. So leptin, when it's in high concentration, which is usually when we're full, when we're consuming enough that we're gaining weight, then leptin levels are kind of at their maximal level. And that leads to this increase in platelet aggregation. But I don't want you to necessarily think of leptin as this terrible thing. It serves its function. It's just there's too much of that function. That's really the bigger problem. Finally, resistin is, as I've mentioned, is one that I need to educate myself a little bit more on. But it leads to the exact opposite of what adiponectin does. And I'll go into a little bit more of the mechanisms a little bit later on, but resistin increases the level of these monocyte attractions to the endothelial cells. So if you have increases in resistin, then you have potential increases in this monocyte attraction. So is that something that you want? Well, it very much depends on the circumstance, but if you are overweight or if you have cardiovascular disease issues like high cholesterol, then no, it's not. And like I mentioned, all three of these hormones are mainly released by the adipocytes, although they can be released from other areas. Now, just as a quick aside as well, it's just something that they mention, but isn't. I mean, it's just interesting information, but it doesn't really play into the overall study, is that where fat mass is located. So being over fat in general is of course problematic, but also the location of that fat mass makes a big difference in terms of your overall health, and as well as the release of these adipokines. Again, these adipokines are the hormones that I was talking about earlier. So if you have fat that's subcutaneous, so if you think of like getting those washboard abs, that is a release that you're trying to get rid of subcutaneous fat. That is actually less harmful fat than what is known as visceral fat. So those are around your organs. That's not stuff that you actually really see. If you were to do an autopsy on someone who's massively overweight, however, and they have a lot of visceral fat around their organs, then you'd be able to see that. I mean, it would be very marbly. And you can certainly see that if you ever look up pictures of like the heart, and it's got that marble around it, that kind of white around it. That is the accrual of fat. So that's visceral fat. And that is more detrimental. So it leads to a dysregulation of these adipokines. It leads to increases in leptin. It leads to increases in resistin. And it leads to decreases in adiponectin. So if you have the same level of fatness, let's say a person is 25% body fat, and one person has more visceral fat and another person has more subcutaneous fat, the person who has more subcutaneous fat as opposed to visceral fat, even though they have the same level of fatness, will tend to be a little bit healthier than the person with more visceral fat. I just wanted to throw that out there because I think it's really interesting, and it should hopefully illuminate this idea that we shouldn't look at just overall fatness as the only marker of health. We should definitely be focused on where that fat is located, which is largely dictated by our genes, and we can also affect it by our lifestyle, simply by reductions in fat or increases in fat. So now let me go into the study design a little bit. I'm not going to go too in depth with it. I'll probably have more content on this particular study because it does tell us some pretty cool information. It's pretty straightforward, which I really appreciate. So the participants were middle to older age. They were, I believe, around 45, 46 years old. You had some people that were, I believe, in their 60s. The body weight was kind of all over the place. Most of the participants were women. So obviously body weight is going to be pretty out of whack because the men are going to be heavier. They had 12 women and they had 4 men, so certainly skewed more towards women. I believe they may have run some statistical analyses for specifically the men to figure out if there are any differences, but it's kind of hard to do when you only have a pool of 4. So I'm not going to be discussing that. So overall, just as a pool together, all the participants, so all 16 participants, had a few differences, but mainly that's because of their sex, right? Men are just larger, so of course they're going to weigh more. All of these participants were overweight, from what I remember. Yeah, so they were all overweight, but they had to be weight stable for about 3 months, within a few kilograms, which is actually a pretty large difference. A few kilograms in 3 months is pretty sizable, but still, that was their criteria. And they had to be non-diabetic. And this is the one that I'm actually really interested by, is the fact that they had to have no cardiovascular issues. So unlike other studies that would look at cardiovascular issues, in this situation, they had no cardiovascular issues. So we're going to see how alternate day fasting has an impact on people that don't need it, in a manner of speaking, as in their body is not in a pathological state. They have normal cholesterol, they have normal HDL, normal triglycerides, normal blood pressure. So they don't have cardiovascular issues. But we're going to see how ADF still has an impact on these various markers. They also had to make sure that they were not on medications, which makes sense. They probably wouldn't be, at least not for cardiovascular disease. And the women that were included were pre and postmenopausal. So that can certainly lead to some variability in the data. But luckily that ended up not being the case. But it can, if you were to design a study, that's something that you want to take into consideration. The study overall was 10 weeks, so not extremely long, but certainly enough to actually end up finding an effect, as we'll see. So how it was designed, if I can get this up for the people that are watching. Okay, so how it was designed was You had the first 2 weeks, the participants were told to stick to their previous diet. So they were told to eat at a maintenance that was established for them. The researchers figured out, okay, based off of the various calculators, we figured out your maintenance, and we want you to stick to this particular number, but eat, however you normally do. So that's for the first 2 weeks. They did measurements, blood measures at the beginning of those 2 weeks and then at the end of those 2 weeks. And then they had days 15 through 42. So for the next 4 weeks, then they told them to switch to this ADF, so this alternate day fasting. So with the ADF, as I explained earlier, they were allowed to eat really as much as they wanted to on the days that they were technically allowed to eat. And then the fasting day, they ate 25% of their maintenance calories. So they ate drastically reduced numbers of calories or food in general. Now, during this first portion, this first 4 weeks, the big difference was that the food was supplied. So the participants would go to the lab, and they had cooks, they had people that were making the food for them, so that it was a lot stricter in terms of hitting their, or staying within that 25% and making sure that they weren't going all over the place with their food consumption. Now, in the second portion, so far we're 6 weeks in, right? We have the 2 weeks baseline, 4 weeks of the actual ADF, and then the next 4 weeks, they still stayed on alternate day fasting, but the participants were asked to maintain the same exact protocol. So they were still alternate day fasting, but the difference was that they were free living. So meaning that the food was not supplied now. So now it's up to the participants to stick to that 25% or 75% reduction in calories. And again, they're taking measurements at the beginning of each 4-week block, at the end of each four-week block. And what's interesting here is that they also took measures on a feeding day, so the day that they consumed food, and then on a fasting day. And this is really interesting because then it allows you to compare between, are there differences based off of the outcomes that we want to look at between, one day to the next, if you're fasting, quote unquote fasting, or if you're having a full day of eating. Okay, so now, that is how they went about the study. Now let's look at the results. Okay, so table 2, if you do pull up the study, which is linked for you, table 2 just goes over a variety of different factors. And I believe I have that. Oh no, apparently I don't. For anybody watching, sorry about that. I thought I did. Well, let me check real quick. No, I don't. Actually, yes, I do. Let me pull that into this view. Hopefully it'll work. Yeah, it's not ideal, but it'll work. At least it's up there. Okay, so for table 2, you see that there's decreases in body weight. So this is, that makes sense, right? You're going to see decreases in body weight. And the decreases in body weight are linear. So what you're doing really here is comparing the baseline values, not really day 1 to day 14, although it's important because you want to know that there's consistency in those first, baseline control data, but really comparing day 14 to really any other day that you see in the data. So you're comparing the baseline data of those first 2 weeks to the first 4-week mark, the end of the first 4-week mark, as well as the end of the 8-week mark. So the end of the study total, which is the full 10 weeks, 2 weeks plus the 8 weeks of intervention. And you see that body weight decreases linearly, which makes sense. You would certainly hope that if people are massively under consuming on, every other day of the week, you would think that they would lose weight. And they did. They lost pretty substantial amounts. So they lost about 6 kilograms, which equates to roughly about 13 pounds over technically an 8-week period of them implementing this. So over 8 weeks, they lose 13 pounds. Not bad. That's not shabby at all. So on feeding days, so the days that they measured the actual, when participants were allowed to eat and then they went to the lab and had things measured, on feeding days they had a higher weight and had more lean mass. Maybe you can already figure out why that might be the case, but I'll go ahead and tell you. Why they had higher weight was because, and as postulated by the researchers, why wouldn't you have higher weight, right? If you've just consumed a whole lot of food, then you're going to be heavier. And if you're consuming a lot of liquids, then you're going to be heavier. And then if you translate that to, let's say, glycogen production, you're going to have some glycogen production. You're certainly not going to be at where you normally would be. So those are a few factors that would throw that off. Is that really that interesting? I mean, it's interesting, but it doesn't really add anything. However, something that is interesting is changes in fat mass. So if you look at, we said that body weight was decreasing. What happened to fat mass? Well, fat mass decreased. Fat mass decreased quite substantially. The way I see it is around 5 kilograms of fat mass. So most of the body weight was from fat mass, and most likely the rest of it was probably from things like glycogen or some, certainly other factors that fit into that 1 kilogram, water weight, whatever it might be. And the next thing that I find really interesting that I wanted to cover is because, for the title of this particular podcast, I throw in, muscle. So here they look at fat-free mass, and I believe they used a really precise technique to figure this out, or as precise as we can get, which is a DEXA scan. I believe that's right. I could be a little bit off on that. But regardless, they show fat-free mass, which is mass that is anything other than fat itself. And that's, like bone, that's your organs, that's your muscle mass, which obviously your muscle mass makes up the majority of that. So is it specifically telling you that muscle mass is changing or not? Well, not necessarily. But if you don't see a change, then you can attribute that to no change across the board. So what do we see? Well, the baseline value was 51.4, and which is on day 14 of their baseline control diet. And then at the end of the study, they were at around 51.9 on a fasting day. Now, I don't want you to take that and think that they gained muscle or anything like that, because these individuals, from what I understood, were not exercising or not religiously exercising or anything like that. So they didn't gain muscle. They didn't gain fat-free mass, but they did at least maintain. So I think that's really interesting, because if you think that you're losing body weight, you're losing body fat, and people are so scared about losing muscle mass, especially when these people aren't even exercising all that much, if any, then this at least shows you that in 8 weeks' time, if you're overweight and you're trying to get to a lower weight, you're not going to be losing any sort of appreciable amount of muscle mass. So, kind of cool. Okay, so let me get rid of this and let's move on to figure 3. Now, figure 3 is where we're going to start talking about some of these hormones. So again, the 3 hormones being adiponectin, leptin, and resistin. So adiponectin, if you are, again, watching, I will throw that up. I don't have all the graphs because I'll be covering this in more detail in the future. But adiponectin is that one hormone that you do want to see increases in. And if you're watching, you want to be comparing the green to the green. At least that's probably the main comparison that you want to make. And I put a few added bonus information in there just so it'll orient you well enough. Okay, so adiponectin is involved in increasing, or actually decreasing, that monocyte adhesion or grabbing onto those LDL particles. So it's a good hormone, quote unquote good. I don't like to say that any hormone is good in every context, because it's just not going to be the case. But ultimately, you see this increase in adiponectin, but not in the first 4 weeks. So what does this tell us? It tells us that most likely adiponectin takes a while for it to increase, for it to go above kind of basal levels. And I should have mentioned this earlier, but interestingly, the participants were able to stick to their diet, to this ADF, through all 8 weeks. So even with the 4 weeks, obviously with the 4 weeks where everything was nicely controlled and created for them by the researchers, the food and all that stuff, it was nicely modulated for them. However, in the final 4 weeks, they were essentially on their own, and they were told, "Hey, can you stick to this? And we'll measure you at the end of the 4 weeks." And it seems like the participants really did do that. So this might lend some credence to the idea that, well, maybe this is relatively sustainable. It's pretty easy, right? It's eat on one day, don't eat on another day. It's really simple. So if you can stick to that, then that's great. So what does this mean for adiponectin? Well, for those first 4 weeks, while they're sticking to this diet really strongly, you don't see increases in adiponectin. But with the next 4 weeks, so over an 8-week period, you do see increases in adiponectin. So it's helping in decreasing inflammation. That's another factor that it has. It decreases overall inflammation. It decreases that atherosclerotic potential. And it also is involved in blood sugar regulation. And keep in mind that although they don't actually show the blood sugar levels for these individuals, these people are non-diabetic. But with this adiponectin increase, you would also see better clearance of blood sugar. So this would mean that you become more insulin sensitive. So that would be beneficial for diabetics. And you also see reductions in liver sugar production, because you don't really want that. You want that to a degree to keep you alive, but you don't want that overabundance of sugar production. So it has a host of different beneficial effects when you are trying to really just improve your overall health. Now, of course, this is technically confounded. We can't necessarily say that the benefits that we're going to see kind of down the road as we go through this data is specifically to adiponectin. They didn't make that connection, and we can't make that assumption. But what we can say is, based off of other literature that's been based on adiponectin, we know that it has a lot of positive effects for individuals, specifically if they're overweight. But just in general, it's quite helpful. Okay, so that's adiponectin. Now, I want to touch on leptin, which I do have that information as well for everybody watching. So leptin is that hormone that, again, is in control of maintaining the energy state of the body, but it also has an impact on the aggregation of those platelets. So it, if you have high levels of it, too much of it, then you have a higher risk of that thrombosis that I was mentioning earlier. So what do we see with leptin? Well, we see a pretty sizable drop. Within the first 4 weeks of the alternate day fasting, you see a drop in leptin. So great to see. And that's exactly what you'd expect. Any weight loss diet that a person takes on is going to lead to drops in leptin. And they can be pretty quick. I mean, within like a week, you're going to see drops in leptin, as long as you're dropping body fat, because it's really a signal. It's released by those adipocytes, and the adipocytes continuously release leptin when you are normally eating and you're not trying to drop fat. You're kind of maintaining your weight or you're increasing weight. During those times, leptin is high. As it's released from the fat cells, it goes through the blood system and it ends up at the brain. And in the brain, in the hypothalamus specifically, you get these regulations of consumption, you get regulations of metabolism, like how active you are, things like that. So, and which is stuff that I've spoken on actually just last podcast, looking at the set point theory, body weight set point theory. Okay, so you see decreases in leptin. Not too shocking, but that's to be expected, and it's encouraging to see. Now, the next one I don't have the actual data for, but if you can always hop onto the paper yourself. And resistin, again, same effect as with leptin. There are decreases in resistin in the first 4 weeks that end up persisting over the last 8 weeks. So the two hormones that you want to decrease in a situation where you're trying to improve your health if you're overweight do decrease, and the one hormone that you want to increase does increase. So overall, this is I don't want to get too out there, but it's kind of a healing environment that these individuals are creating for themselves with this alternate day fasting. Okay, so now moving on. Well, I guess just real quick, I do want to quick add in that resistin. Another thing that resistin does is it suppresses glucose uptake, so blood sugar uptake from the bloodstream, and it suppresses that from entering the cells, meaning that then you have higher blood sugar levels as a result because you have increased resistin. So it kind of resists the glucose uptake, and it also suppresses or decreases insulin sensitivity. So some things to keep in mind there. I mean, you're clearly seeing this kind of antagonistic role between adiponectin and resistin. Adiponectin in this situation is increasing to improve glucose uptake and improve insulin sensitivity and reduce inflammation. Resistin is decreasing, which is good because otherwise it would make glucose uptake worse and insulin sensitivity worse. Okay, so now let's go on to cholesterol, which is kind of the last bit of data, and then I'm going to wrap this up and put a pretty little bow on it, and we'll see what we can really take away from this. And certainly, if you have differing opinions, I absolutely love it when people engage in critical, polite, critical dialogue on something. So I'd be definitely interested in your take, different interpretations of the data, as well as just your overall thoughts. So let's go into cholesterol a little bit, which is really one of the main outcomes that they were looking at, right? I mean, this paper is supposed to be looking at cardiovascular outcomes, but keep in mind, and I really want to make sure that you're aware of this. This is in individuals that have normal cholesterol. They're not in any pathological state. They don't have any cardiovascular disease. Even though they may be overweight, they're still technically healthy based off of their cholesterol measures and blood pressure. So what do we find? Well, total cholesterol, which is, I'm not going to go into too much of cholesterol. I've had people try and correct me about cholesterol in terms of, well, you're not technically talking about cholesterol here. You're talking about lipoproteins. And yes, that's true. But the lipoproteins, they're vessels that hold cholesterol in them. So when you go to the doctor, your doctor's talking to you kind of in a standard way about cholesterol, but really they're talking to you about your lipoproteins. And that is very low density lipoproteins, intermediate density lipoproteins, and high density lipoproteins. And there's different iterations between those, different versions of these vessels. And they really are just like packages. Think of them like UPS. They're just packages, and they're just stuffed with fat and cholesterol, the actual molecule cholesterol. So LDL cholesterol is produced, well, it's really produced as VLDL cholesterol. And as it goes through the entire system, it's produced by the liver, and as it goes through your entire system, it delivers cholesterol to all these different cells. So it is absolutely necessary for it to exist. Otherwise, you do not exist if you do not have LDL cholesterol. However, you don't want too high of levels. And you want pretty high levels of HDL cholesterol. So HDL cholesterol then brings cholesterol back from the periphery, from the other tissues across the body, and brings it back to the liver to be repackaged or to be dumped. So you have this kind of this interplay between LDL cholesterol, HDL, VLDL, IDL cholesterols. And triglycerides also get thrown into the mix. So all of those combined, HDL and LDL, for example, combined make up your total cholesterol. And what do we see? So what does the data show then? This is based off of baseline values. So that's why, if you're looking at the data, that's why you're not seeing the actual baseline like you were before. That's because they're showing the change, the actual percent change off of baseline. And fascinatingly, you see a pretty sizable change in cholesterol. I'll be going over the percentages as I go into the conclusion, but you do see sizable drops in total cholesterol, which is really encouraging to see. But what you'll also notice is that there's no increase in the effect. So the effect happens within the first 4 weeks, and then does it increase after the next 4 weeks? The answer is no. So you get this initial drop in cholesterol, and then it just stays there. It plateaus. It continues from there exactly at that level. So that's certainly interesting. Now, LDL cholesterol, so that was total cholesterol. LDL cholesterol does the exact same thing. It also decreases. Triglycerides, which are fat molecules, also decrease as a result. And interestingly, the HDL, so something that you typically want more of, did not change. So alternate day fasting did not have a positive or negative effect on HDL after 8 weeks of that implementation. So pretty interesting there. You do see increases in HDL from something like exercise, aerobic exercise, cardiovascular exercise, steady state cardio. You do see increases in HDL, but like I said, they weren't implementing that. So what does this mean? Well, okay, so what conclusions can we take away, or what primary conclusions can we take away from this? And if you end up kind of figuring out something else, certainly comment in whatever social media platform you want is preferable to you, and I'd be happy to hear your thoughts. So ADF, alternate day fasting, does reduce body fat, but it does not reduce lean mass over an 8-week period. Great. That's fantastic news. ADF increases adiponectin, but the effect is delayed compared to leptin and resistin, which both of those decrease within the first 4 weeks. Even though they didn't show this, I can tell you leptin probably decreased really, really quickly. I don't know about resistin, however. But adiponectin, the first 4 weeks, you don't see a change. And then after those first 4 weeks, so within week 5, 6, 7, and 8, you see an increase in adiponectin. So there's a delayed effect, but it does occur. ADF improves cholesterol. Now, what percentages? So about a 21% reduction in total cholesterol. That's massive. That's a huge decrease. Now, of course, that's confounded by the fact that you have weight loss that also occurred and fat loss. But still, who cares, right? Applicably, who cares? If you see weight loss, if you're underweight, of course, that's a huge problem. You don't want to be losing weight, but then you probably shouldn't be doing alternate day fasting. You should be probably not doing any fasting whatsoever, but I digress. That's a problem for another day. The point being, you see decreases in body weight, you see decreases in body fat mass, you see no change in lean mass, which is great, and you see decreases in this cholesterol, 21% reduction. Triglycerides dropped over 30%, so an even greater decrease. And it also decreased LDL cholesterol, so that quote-unquote bad cholesterol. But like I said, you have to have LDL cholesterol, and that decreased by about 25%. But interestingly, there was no change in HDL cholesterol. So what's the big takeaway here? ADF is, and I have this written down so I can make it nice and succinct. ADF is an efficient, low thought way of reducing body weight, mainly from fat mass, while preserving lean mass, while also decreasing cardiovascular markers like cholesterol and triglycerides in people, and this is the big key point here, who are not suffering from cardiovascular disease. A lot of the studies I've covered in the past have been in individuals that have suffered from cardiovascular disease. So this is too cool. That is too cool that that people that are perfectly healthy in their in a variety of cardiovascular disease markers, still see a benefit from alternate day fasting, in conjunction, of course, with the confounding factor of weight loss, fat loss. Okay, that's what I've got for you. Hopefully you found this informative. I thought this was a really straightforward, nice, easy paper to go through, but it certainly tells us some great information that we can go forward with. So, like I said, I hope that you found this informative. And if you did, then I would certainly appreciate it if you reviewed the podcast, if you're listening to this, and leave a like once this podcast actually goes up on the channel, on the YouTube channel, and share and subscribe if you haven't. And with that said, I hope to have the absolute pleasure, as usual, of speaking with you in the next one. Have a good one, guys. See ya.